we're going to be focusing on 10.1, the economic order quantity model, or the EOQ, which in general is just calculating the total cost at where the ordering point is most optimal. Okay, so please go over the chapter. Again, you don't have to memorize the formulas, but it's interesting for you to just go over more than just the EOQ model. All these definitions, for example, right here, capital C and then small h, this stands for the annual cost of holding of one unit in inventory, which we're gonna need that. But to find this value, it also tells you that you need to multiply the annual holding cost rate times the unit cost of inventory item. This is gonna make more sense when you go over the problem because it's gonna tell you exactly that. For example, annual holding costs are 20% of the value of the inventory. So right here, you would have this value. The annual holding cost rate is 20%, and the unit cost of inventory item. So let's go back here. The unit cost is $2.50. So right here, you would have defined your holding cost, which would be your 20%. Remember, for Excel, we always start with the equal sign. So I'm doing 20% right here, and I have put the formulas here as well. And if you look at holding costs, I said that right here, I times C. So I is the holding cost rate, which is 20%, times the unit cost, which is 250. So your holding cost is zero point 0.5. We already have one of the values that we're going to be using. For this chapter, we also going to be using uh, this formula right here, which is the total annual cost. And to find that, you have to calculate the annual holding cost plus I really don't like every time I try to highlight something, it does that. I like the other book better, but those are different publishers. Plus annual ordering cost, which I also have put the formula over here for you, and we're gonna go over. Okay. What else? Yes, uh, this formula, especially this formula right here, the Q asterisk, it's gonna represent its, see, this formula is referred to as the economic order quantity. Please note that throughout the chapter, if you see the Q without the asterisk, is different than the economic order quantity. Okay, so don't get confused. So in this case, every time I see the Q asterisk, I'm gonna be using the value for the EOQ formula. So we're gonna actually start with that. What else from here? Yes, and then we have other models. So let me just minimize the book here. I have put problem 4. I'm gonna go over problem 4, and then I'm gonna stop the video and I'm gonna go over problem 9, and then you'll have both homeworks for this week. So again, problem 4 and 9 are for the EOQ section, and pretty much is the number of units that a company, they're trying to determine the number of units that company should add to the inventory with each order to minimize the total cost of inventory, and such as holding costs, order costs, short costs. Another important thing is that one question that I put on your discussion in regards to holding costs. I believe I said once we understand how the EOQ model helps to balance holding costs and ordering costs, we realize that as one goes down, the other one goes up. Why is that? And how does it work? Well, if you think about it, the way I see it is rather than making multiple orders and you getting charged every time you order because you are going to get charged for the orders. You make one b- bigger order and pay for that once. Well, your holding costs, they're they're gonna increase, right? You're going to hold that those products, so your holding price would increase since now you need more space to hold those items. And also the holding in on the other side, on the other hand, the holding price would decrease if you make smaller orders and you have few items to hold, to store, then your order cost would increase every time you order because you're making smaller orders. So the best thing really, if you could take advantage of ordering savings, is to make larger orders to hold the items. But then you also have to consider if you have room to um, hold all these items. So it's a very interesting concept, and it does helps managers to look at all these numbers and make a decision should they what would be the best decision. Should they order more? Should they order less? If you put everything together, in general, am I gonna save more if I order more and hold, and my holding costs maybe are not going to be as high as if I make smaller orders and order more often. So it's very interesting to see all that in play. So let's go ahead and over problem 4 to see if it makes more sense as far as the calculations. And I have put it here. First of all, that you need to know the demand, the capital D stands for the annual demand. The small d, it stands for daily demand. And most of the problems assume 250 days for working days. They are excluding weekends, they are excluding holidays, and some also in most of the problems will if you're not given the specific number of working days, do assume 250 days. That's the most common that you're going to be seeing. Okay, so C, the capital C, and then the subscript O, it refers to ordering costs. I for interest. The C on its own is the unit cost of an inventory item, in this case right here, ordering cost. And for the C, subscript H is holding costs. But to get your holding cost, you need to multiply the interest time the unit cost. We already talked about the small d for daily demand. M, not sure why M, but it's the lead time for a new order in days. That means the time you wait from the moment you order to the moment you receive the product, the lead time, pretty much the wait time. R is for reorder time, which I have put the formula right here. In order to calculate the reorder time, you need to do daily demand times your lead time. Okay, T stands for your cycle time, which you're going to be asked all that on the problem. That's what I put it here. And the main one, what is your economic order quantity? So the formula for that is going to be square root, and that's in your book, of square root of the numerator 2 times the annual demand right here times the ordering cost divided by, I wish this would, um, why, hmm, divided by your holding cost, which is your interest times unit cost. So again, don't memorize all this. As long as you just need to make sure that you have the correct numbers for the problem, and then with the formula in hand, all you have to do is to substitute by what the information you gathered before. So another thing I put it here that might help you. Here we go. What is your demand, your annual demand? Let's read. Westside Auto purchase a component using the manufacturer of automobile generators directly from the supplier. Westside's generator production operation, which is operated at a constant rate, will require 1,000 components per month throughout the year. Well, 12 months, 1,000, so 12,000 units annually. So your capital D or your demand is 12,000. Assume that the ordering costs, assume that the ordering costs are $25 per order. $25. So we know this is dollar, which we could put it like this. These are days, correct? Your holding cost, which I have done before for you, it's gonna be the 20% times the unit cost 250. So this we know is a dollars amount. Well, and then it's telling you right here, we're gonna, oh, let's continue right here. Assume that the ordering costs are $25 per order, the unit cost is 250 per component, and annual holding costs are 20% of the value of the inventory. Westside has 250 working days per year and a lead time of 5 days. Your lead time is five, right here. Okay. And actually, I'm just going to put in the center. It doesn't matter. So we know this is days, this is days, this is dollar amount. Right here, how do I define my daily demand? Well, if we have at 12,000 units annually and we have 250 working days, so all we need to do is to do the 12,000. I was going to point to the cells, but I don't want to confuse you. Divided by daily demand times lead time. There's your reorder time, correct? And then now we have this cycle time. Your cycle time right here, you have this formula. It's going to be 254, 250 working days times your EOQ right here divided by your annual demand. Well, we haven't answered this one. And right here to do your uh, total annual holding and ordering costs, which is your total cost, we also need the EOQ. So right here, we're actually going to have to calculate this one. And since we're going to be calculating the EOQ, you're going to be answering A, so we can actually put the formula over here. So your EOQ, which is the economic order quantity, or in your book, the Q asterisk, so you're going to do square root of 2 times the annual demand times ordering cost divided by the holding costs. Well, we have the holding costs, we have the ordering costs, we have the annual demand. So all we need is to put in a formula. So equals to the square root, I'm following this one right here, 2 times your annual demand times your ordering cost divided by your holding costs, which I already calculated before, correct? Let me see if that works. Here we go. It should be 1,095. Actually, if you have more digits, you're gonna see 1,095.45. Well, but it says what is the EOQ or the economic order quantity? So here we're talking about unities, correct? Well, it's not possible for us to have 1,095.45. Some of you might get 44 unities. You don't have a 0.45 unities. So right here, um, this can open room for so much discussion. You could round this up or you could round this down. You really have to look at all your values and the cost and make a decision. Is it more, um, is it a better choice to round this up or to round it down? Or even you don't have to do 1,095. Maybe if you would go ahead and round it up to 1,100 instead of just 100 and 1,096. Or you could even uh, round it down to 1,000 if you want to have a number that makes easier for everybody to understand and you don't have all these broken digits. In this case, I'm gonna leave it like this, but this opens discussion for managers that might tell you, hey, what about if we increase that? And what about if we decrease that? Overall, in a year, is that going to benefit us or is that going to go against us? And what about the holding costs? What about the ordering costs? How does that, what modifying this, rounding up or down, which this is the most optimal, you shouldn't change this value. But if you do, would it benefit the company? So this is something that managers do discuss. Right here, I'm gonna leave it as it is. So for the formulas, so they can play it right. But you could go ahead and make a choice what to do. And on your homework, I won't be deducting any points if I see that you just made a choice. As long as I can see your calculations, everything's fine. Okay, so now is asking for your reorder point. Well, I told you that R for your reorder time, but your reorder point is going to be your daily demand times your lead time, which you already calculated right here. Remember? So let's do it again, just as a reminder. Your reorder time or your reorder point should be the daily demand times your lead time. So your reorder point is when you get to 240. Okay. Your cycle time, how long should you wait to place another order? So your cycle time right here, it's gonna be T and is this formula over here. Well, now that we have calculated EOQ, we have everything we need. We have the 250 working days times my EOQ, which is the 1095 units, which I'm rounding down, divided by my annual demand. So that's what we're going to do here, equals to, so 250 times, so 250 working days, correct? Times 1095, or I'll just leave it as it is, divided by my annual demand. Well, we know the annual demand is 12,000, correct? And I really don't mean to confuse you. Sometimes I do refer to the cells, sometimes I don't. Again, you can follow what is better for you. So when I look at your formulas to make sure that you have completed correctly, I'm not asking you to follow exactly what I do or to follow the cells. As long as I can see your calculations, for what I care, you can type out the numbers, you can just refer to cells, or you can include the formula. What is best for you, it works with me. So right here, our cycle time should be, well, again, these are days, correct? So, well, we're probably not going to do 22.82. In this case, usually you would round it up, but again, how would play overall? Would be better to round it up or to round it down? That's another discussion right there. So here's being very precise. And lastly, what are the total annual holding and ordering costs associated with our recommended EOQ or quantity order of 1095? And these are the formulas in order to get the total of both, which you're gonna calculate one, you're gonna calculate the other, and then you're gonna sum them. So right here, I'm going to be doing this formula over here. I'm going to do this formula over here, and I'm going to sum both over here to give your total costs. Okay, so let's follow this first formula right here, which these are for your holding costs right here. See the H for holding costs, O for ordering costs. So all I'm doing is following the formula. So we're gonna do have times my EOQ right here times, and I refer to the cell because I want to use the exact amount of digits times my holding cost. Where's my holding cost? Right here. So my holding cost is going to cost me 273.86 $273.86. Ordering cost, actually, I should put this in parentheses because is the demand divided by the EOQ, so it's Q asterisk times my ordering cost. So right here, it's gonna be my annual demand divided by my EOQ times my ordering cost, which is coincidentally is exactly the same. So right here, it's giving me, not coincidentally, it's just telling me that by my optimal EOQ point, I'm gonna spend $273.86 to hold, and I'm gonna spend 273.86 to order. So that's why the whole, should we round it up, round it down? So the total really that would cost would be the sum of these two right here. So my total cost would be to hold and to order of $547.72. And you would be done with problem 4. So again, I don't plan for you to memorize all these values. I just need you to, oh, right now we have this value here, right? Which my cycle time. Sorry about that. It's just so you have to understand or to translate the problem into this variables, and therefore you're able to plug into the formulas, and then you're gonna have your answers. Okay, so do think about what would happen if this would go higher, if this would go lower. What would be better? Would it be better to place smaller orders? Would it be better to place larger orders, but then your holding costs are increasing? Or in smaller orders, then your holding costs decrease, but then you pay more to order every time. So it's a very interesting concept. And as usual, let me know if there are any questions.